Welcome back to Security for Legal SaaS. I'm Alice.
And I am Dan. Episode 48, Environment Configuration and Secure Defaults. Alice, this sounds deceptively simple. Configure your environment properly, but I have a feeling there's more to it.
There is. Let me ask a question. Your legal SaaS platform, your contract review tool, your case management system runs in multiple environments. Development, where your engineers build features. Staging, where you validate before release. Production, where real law firms use it with real client data. Here's the question. Are the security controls the same in all three?
Ugh. I suspect the answer for most teams is no.
Almost universally no. Teams disable authentication in development to make testing easier. They skip rate limiting and staging because it slows down integration tests. They turn off audit logging in development because it fills up disk space. Each of these seems harmless. But what they're actually doing is testing a different application than what their clients use. Every feature built, every test written, every integration validated, all without the security controls that production depends on.
Right. And then when those features hit production, they're encountering authentication and rate limiting for the first time.
Exactly. And that's where the bugs live. A race condition in your authentication middleware that only shows up under real traffic. An API endpoint that works perfectly without rate limiting, but behaves unexpectedly when rate limited responses come back. Debug information leaking in error messages. Because debug mode was always on in development, and nobody thought to check what happens when it's off.
So the principle is keep security controls active everywhere.
The principle is environment parity for security controls. The difference between your staging environment and production should be credentials. Different database passwords, different API keys, and scale. Not whether authentication is enabled. Not whether you have rate limiting. Not whether you're logging audit events.
Yeah, but practically, how do you make development workable if authentication is always on? Developers don't want to log in every time they restart the app.
You use test accounts and local identity providers. The authentication middleware stays active. The same code path that runs in production runs in development. But instead of connecting to your production identity provider, it connects to a local one with test credentials. Developers log in with dev.test.local and password test. The point is that the authentication code is exercised. The session management works. The cookies are set. Everything downstream of authentication, authorization checks, audit log entries, rate limiting tied to user identity, functions correctly.
That makes sense. What about configuration management itself? Where does all this config live?
This is where teams get into trouble. The 12-factor app, an influential set of principles for building modern web apps, establishes a clear rule. Configuration that varies between environments must be stored separately from code. Not hard-coded. Not in a config file checked into your repository with the production database password. Environment variables are the simplest approach. Your deployment platform sets them, your application reads them.
Right, but environment variables for secrets. There are concerns about those being visible, aren't there?
Good catch. Environment variables can show up in process listings, crash reports, and debug output. For non-secret configuration, is rate limiting enabled? What's the session timeout? Environment variables are fine. For actual secrets, database passwords, API keys, encryption keys, the best practice is an external secrets manager. HashiCorp Vault, AWS Secrets Manager, or your cloud provider's equivalent. The application authenticates to the vault at startup and retrieves only the credentials it needs. The secrets are short-lived, automatically rotated, and every access is logged.
So that's configuration management. Let me ask about secure defaults. What happens when no configuration is provided?
That's the critical question. A default is what your system does when nobody explicitly configured a setting. Secure defaults mean the out-of-the-box behavior prioritizes safety over convenience. Authentication is on by default. HTTPS is required by default. Debug mode is off by default. Session timeouts are set by default. CORS, which we covered in episode 12, restricts origins by default. If a developer spins up a fresh instance and does nothing, the application should be secure.
Yeah, and the opposite, insecure defaults, means a fresh instance is vulnerable until someone remembers to configure it.
Exactly. And here's the design principle. Make the secure path the easy path. If a developer has to do extra work to make the application less secure, pass a special flag, set an environment variable, modify a config file. Most won't bother. That's what you want. If they have to do extra work to make it more secure, many won't do that either. Security should be the path of least resistance.
Let me ask about feature flags. I've seen teams use feature flags to control security settings, enable auth as a flag. That seems problematic.
It is. Feature flags, runtime switches that enable or disable functionality without deploying new code, are a powerful tool. Rolling out a new content security policy to 5% of users? Great use of a flag, but using a flag to toggle core security controls is dangerous. A flag called enable auth, that's false in development and true in production, means authentication is a configurable option, not a foundational control. Somebody, an engineer, a script, a misconfiguration, can disable it. Core security controls should be always on and unflagged. Authentication, authorization, encryption, audit logging, these are not features you toggle.
Right. What about using flags for new security features during rollout?
That's the correct use. You're introducing a stricter content security policy. You flag it, roll it to 5% of traffic, watch for breakage, increase to 50%, then 100%. Once it's stable, you remove the flag and make it permanent. The flag exists during the transition period only. Best practices say, clean up flags aggressively. A flag that's been 100% enabled for 3 months is dead code that someone might accidentally toggle. And treat the feature flag system itself as security critical. Production flag changes need review and approval, just like code deployments.
One more angle. When security controls differ between environments, what actually goes wrong?
3 things. First, bugs hide. A race condition in your authentication middleware only manifests under real traffic patterns, with the middleware actually running. You never see it in development because auth is disabled. It appears in production during a demo to a major law firm. Second, developers build around security. If auth disabled locally, developers write tests that skip authentication headers. Those tests pass in CI but break, or worse, miss real vulnerabilities when auth is active. Third, configuration drift. Each environment diverges. Staging gets a temporary course exception. Development gets debug mode permanently. Over time, staging stops being a reliable predictor of production behavior.
Yeah, that's a slow erosion that's hard to notice until it's a problem.
And for legal SaaS specifically, where you're handling privileged communications, client documents, matter data, the professional obligation adds weight. If a breach traces back to a security control that was disabled in your testing environment and a resulting bug that only appeared in production, the question from the regulator is going to be, why were you testing with different security controls than what your clients rely on?
Strong point. Next episode, Cloud IAM and Least Privilege. How you manage who and what can access your cloud resources, and why that service account with owner permissions is one of the most dangerous things in your infrastructure.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.